Hey guys, welcome to another chemistry video, and today we're going to be talking about molecular polarity. So, molecular polarity is when electrons are closer to one atom than they are to another. And because of this, a partially positive or negative charge is created within the atom. So, polarity or molecular polarity occurs via polar bonds. So, let's take water for example. It has a formula of H2O. So we have an O and then we have H. To describe what's going on over here, basically the electrons that oxygen and hydrogen are sharing, and the electrons that hydrogen is sharing with the oxygen are want to go more closer to this oxygen because it has a higher electronegativity. And we'll talk about that now. So, electronegativity is the likelihood of an atom to attract electrons to itself or to its own atom. And this is one of the periodic trends that we see in the periodic table. So, most times, oftentimes, or actually all the time, electronegativity increases across a period from left to right. So as we can see, lithium has an electronegativity of 0.98 and fluorine has an electronegativity of 3.98. So we can see a drastic difference. And to show that this is not just a coincidence, we can go to sodium. So we see 0.93 is the electronegativity here. But for chlorine, we see 3.16. Although the difference isn't as drastic as before, there's still a large difference, and that shows how electronegativity increases across the period. So as I said before, electronegativity measures the likelihood of an atom to attract electrons to itself. So let's see how it actually comes into play in molecular polarity. So in this chart over here, we have three types of bonds. Nonpolar covalent bonds, polar covalent bonds, and ionic bonds. So today we're going to mostly be focusing on nonpolar covalent bonds and covalent bonds. And we'll get to ionic bonds at another day, but ionic bonds occur when the electronegativity is between 2.0 and 4.0 or greater actually. But the greater, usually the difference of electronegativities never surpasses 4.0 because it hasn't been recorded in the periodic table yet. So over here, and just know that, yeah, electrons are transferred. So unlike covalent bonds that share electrons, electrons are totally transferred. So say H2O was actually formed ionic bonds instead of covalent bonds, the hydrogen would donate its electron to the oxygen. So there would be no sharing involved. Anyways, uh, as we said, what constitutes whether a bond is polar or nonpolar? And it's due to the difference of electronegativity. So let's use water as an example again. So we have H2O. So to determine the difference of electronegativity, we first need to get one. We first need to get one atom electronegativity, which is 3.44, and the other atom, which is 2.20. So now we have 3.44 point minus 2.20. So this is basically the difference of electronegativities, and we get 1.24. So this 1.24 represents the difference of the electronegativities between oxygen and hydrogen. So now if we look for this, 1.24, my bad. So now if we look for this in this chart, we see that it lies between 0.4 and 2.0. Therefore, it is a polar covalent bond. And in polar covalent bonds, the electrons are shared unequally. So this relates to our definition that we talked about before, because the electrons are closer to one atom than the other, so they're shared unequally. And in this scenario, the electrons are closer to the bigger atom than the smaller one because of the charge over here. So this charge over here is called, well, this sign actually is called sigma. So the sigma is, this is how you draw a sigma sign. And this just shows a partiality of something. So you remember how I said partially over here? That's because even though, since the charge that is created in a polar covalent bond is less than 1, it's partial of a charge, and that's why we use a sigma sign. It's because we can't find a definite value, therefore we use a sigma sign to represent that value. So once we get over here, we find that the electrons are closer to the atom with the larger electronegativity because they're attracting electrons, rather than the atom with less electronegativity. So that's why we have an imbalance of the sharing of electrons. So over here we see water, and as I talked before, the electrons of the hydrogen are closer to the oxygen because it has a higher electronegativity, and same for oxygen's own atoms. Let me delete this bond, redraw this, but basically, normally there would be two atoms in the middle. I mean, two electrons in the middle, my bad. But due to the difference of electronegativities, and since it's 1.24, it's a polar covalent bond. So both of these bonds between the O and H are are polar covalent. So the electrons that are being shared are going to be closer to the oxygen atom than they are to the hydrogen atom. And this creates the partial charge that we talked about. So the oxygen is going to have a partial negative charge because the electrons are closer to the oxygen. And since electrons have a negative charge, it's going to add to oxygen's charge, making it oxygen's net charge of 0, making it negative. So we have an S minus charge. And then over here, since the electrons are farther away to hydrogen than they are to oxygen, the hydrogen is now going to have a partial charge, a positive partial charge, because they're farther away. And basically it's losing some of its negativity because the electrons are going away, which increases the net charge. Therefore, it's a bit larger than 0 now.